Hello everyone, my name is Eyal Ginosar, and I'm very excited to present to you our paper, At First Light, Expressive Lights in Support of Drone-Initiated Communication. In this work, we present an expressive light system embedded on drone to convey its intention to initiate communication with a person. Autonomous drones can be used for applications where they might encounter and possibly communicate with bystanders. These bystanders may not be familiar with the technology and may not expect the interaction. One example of this kind of interaction can be for using drones to communicate with trapped or lost people. But to do that, the drone should first follow an initiation of engagement model, similar to what humans do when we meet each other. Adam Kendon defined a human-human engagement model between two people in 6 phases: sighting, distance salutation, approach, final approach, close salutation, and transition to actual communication. These phases are supported by many nonverbal actions that we do, such as creating or breaking eye contact, hand waves, handshakes, and much more. This model has been also previously used in human-robot interactions research. However, when it comes to human-drone interactions, current literature is lacking a full initiation of communication process, and it only covers parts of it. This is why we defined a process for drone-initiated communication based on Kendon's human-human model. As drones' form factors present unique challenges compared to human or humanoid robots, we derived the 6 phases into 3, and we also added a pre-engagement phase. So our process is based on 4 drone states, which is searching, spotting, approaching, and ready to interact. And we wanted to implement a system to support and convey the states of initiating communication, and we chose expressive lights as the feedback modality. Expressive lights were already found to express the state of a mobile service robot and mobile device. They can be seen during day or night. They help in communicating drones' directionality. They are lightweight, and they are easy to integrate. We created 2 prototypes: the strip configuration on the left, featuring a long LED strip in the front of the drone, and the rings configuration on the right, featuring 2 LED rings which looks like eyes. Then we created a total of 26 light animations. Here you can see an example of 4 animations. So we have the chase animation, Morse, one descent, and blink. And some of the animations were inspired by similar designs that were done in research with expressive lights in drones, robots, and computers, and others were generated through discussions within our research team. And to find out what are the best animations for every state, we used Amazon Mechanical Turk and recruited 156 participants for an online study. In the study, participants first saw videos of the animations and were asked to rate their correspondence to each state on a 5-point Likert scale. All the animations were presented in the same color blue, and we chose blue because it was used as the neutral color in previous work and was also found to not have strong association to any machine state. After that, participants chose their preferred color for each state. That was done independently to the choice of animations. Lastly, they answered several questions to assess their perception on the drone. When analyzing the results, we looked at the mean Likert scale rating for each state for every animation. We wanted to find animations where there is one state with a mean score of 3.5 or higher, and which is significantly different than all other states for that animation, as was done in previous work on expressive lights for machine states. This is a summary of all the animations for both configurations. We found 8 animations that matched our criteria. 7 of them were for the same state, searching, 1 for spotting, and none for approaching and ready to interact. However, when we looked at the animations rating for each state individually, we can see a certain trend line that for every state, some animations are more suitable than others, even for the states where we couldn't find animations that met our criteria. These are the results from the strip configuration, and we had similar results for the ring configurations. In the color analysis, we can clearly see the distribution of preferences, with blue and red are highly chosen for searching, red for spotting, orange for approaching, and green for ready to interact. And we used the chi-square goodness of fit test against a uniform distribution to assess if these choices were random or not, and we saw that it was significant for all 4 states. Our next step was to evaluate the system in a close to real-world environment, to see if participants really understand the states and if our system actually supports it. And we compared 3 conditions in a between-subject study design: baseline, strip, and rings configuration. We had a total of 45 participants, so 15 for each condition. Participants were seated outside on our campus and were asked to think of themselves as hikers that got injured and needed help. When positioned, we launched the drone that flew autonomously in a pre-planned path. At the end of the study, we had an interview with the participants, and they also answered several questionnaires. And based on our findings from the online study, we chose an animation and color for each state to be used during the validation study. Here we can see the results from our interviews, and we asked participants what they saw and understood from the interaction with the drone. If a participant mentioned one of the states, we counted it, and here in this plot, we show the percentage of participants' understanding of each state in every condition. And we can see that while searching and approaching were highly identified in all of the conditions, spotting and ready to interact were actually less identified without the light animation. Also from the interviews, we found that color had a bigger effect than animations on understanding the states, with most participants talking about the color they saw, but only a few about the actual animation. We also found that red color was sometimes referred to as intimidating or bad, which was not the outcome that we hoped for, and that green was considered relaxing and communicative. To conclude, in this paper we contribute our 4-state model for drone-initiated communication, the design, development, and evaluation of at first light and expressive light system for drones, and insights on the use of expressive lights to support drone-initiated communications. So I want to thank you for listening, and we invite you to read our full paper for the full details of our work. And of course, we would be happy to hear your thoughts or answer any questions you might have. So please don't hesitate to contact us. And again, thank you very much for your attention.